All right, this lesson is on ellipses. Ellipse is the set of all points in the plane, the sum of whose distances from two fixed points called the foci is constant. Some important parts of the ellipse are the vertices. The vertices are at the end of the major axis. Covertices are at the ends of the minor axis. And the center is the midpoint between both of those axes. And then you have two foci located inside the ellipse. Outside of the ellipse on both sides of the ellipse are the directrix. They're located the same distance away from the vertex as each foci is. Whenever the ellipse is the horizontal dimension is longer than the vertical dimension, then the bigger denominator will be up under the x squared term. Center is just h comma k. The foci will have the coordinate of the foci will have the same y coordinate as the ellipse, and the x coordinates will be plus and minus. You're going to add c and subtract c from the x coordinate of the center. Major axis is y equals k, minor axis x equals h. And then to find the vertices, you're going to add and subtract a to the x coordinate of the center. The covertices you will find by adding and subtracting b to the y coordinate of the center. Whenever the ellipse is the vertical dimension is longer than the horizontal dimension, that means that the bigger denominator is going to be below the y squared term. Center is still h comma k. The foci will be, you'll be able to find this foci by adding and subtracting c to the y coordinate of the center. The major axis is x equals h, minor axis y equals k. The vertices can be found by taking the center and adding a and subtracting a to the y coordinate of the center. Covertices can be found by adding and subtracting b to the x coordinate of the center. The latus rectum is the chord that is parallel to the directrix, but on the inside. Latus rectum is a chord that goes through the foci, both foci, and is parallel to the directrix. You can find it by multiplying 2 by b squared and dividing by a. The length of the major axis is 2 times a. The length of the minor axis is 2b. The eccentricity is going to determine the shape of the ellipse and can be found by dividing c by a, where b squared equals a squared times the quantity 1 minus e squared. If e is close to 0, then the foci is going to be near the center. If e is close to 1, then it's going to be far from the center. Example 1, you've got x squared over 16 plus y squared equals 1. The bigger denominator is under the x squared, so that tells us that the ellipse is going to have the horizontal dimension of the ellipse is going to be bigger than the vertical dimension. The center is going to be at 0, 0. And again, a squared is going to be equal to the bigger denominator. The bigger denominator is 16, so if a squared equals 16, that means a is 4. The smaller denominator is 1, so b squared equals 1. That means b equals 1. And the vertices can be found by adding and subtracting a, which is 4, to the x coordinate of the center. Covertices can be found by adding and subtracting b to the y coordinate of the center. So 0 plus and minus 1. In example 2, we're going to take this equation, which is written in general form, and determine what the center, vertices, covertices, and foci are. First thing we need to do is group the x's and the y's together so that we can complete the square. Move the constant over to the right side of the equation. So in order to complete the square for the y's, first thing we're going to do is factor out a 49. Once we factor out the 49, our linear term is -4. Half of -4 is -2. -2 squared is 4. So 4 is going to complete the square. And we actually added 49 times 4 to the left side of the equation, so we need to add that to the right side. Once we factor that perfect square, we get y minus 2 squared. And then we need to divide all the terms by the constant on the right side, 784. That's going to give us x squared over 49 plus y minus 2 squared over 16 equals 1. The bigger denominator is under the x squared, so that tells us that the ellipse has a bigger horizontal dimension than it does a vertical dimension. So a squared is going to equal 49. That means that a is equal to 7. And b squared equals 16, so that's going to be 4. So c is going to be the square root of a squared minus b squared, so 7 squared minus 4 squared, which is the square root of 33. So the center, according to the equation, would be at 0, 2. The vertices, we're going to add and subtract a to the x-coordinate of the center, and the co-vertices, we're going to add and subtract 4 to the y-coordinate. And we'll get 0, -2, and 0, 6. The foci we get by adding and subtracting c to the x-coordinate of the center. So plus and minus the square root of 33, comma 2. For 3, we want to determine what the major and minor axis lengths are, the latus rectum and the eccentricity. So again, we're going to need to group the x's and the y's together, complete the squares. Once we factor the perfect squares and add what we need to add to the right side of the equation, we get x plus 10 squared plus 4 times y plus 10 squared equals 36. And then we need to divide everything by 36 to get x plus 10 squared over 36 plus y plus 10 squared over 9 equals 1. The bigger denominator is under the x squared, so that tells us that the ellipse has a bigger horizontal dimension than a vertical dimension. And so a squared is going to equal 36. That makes a 6, and b squared is going to equal 9, so b is going to equal 3. C is going to be the square root of a squared minus b squared, so 36 minus 9 is 27. Square root of 27 is what c is. If we simplify that, we get 3 root 3. The major axis is going to be 2 times a, which is 2 times 6, 12. The minor axis, 2 times b, 2 times 3 is 6. The latus rectum is going to be 2 times b squared over a. B is 3, 3 squared is 9, 9 times 2 is 18, and then a is 6, so 18 divided by 6 is 3. And then the eccentricity is c divided by a, 3 root 3 over 6. It will simplify to root 3 over 2. In example 4, we want to take this, the equation of this ellipse, and take it from standard form to general form. So you're just going to multiply all the terms by the lowest common denominator, which is 81. When we do that, we'll be left with 9x squared plus y squared equals 81. And then to finish it up, we just need to subtract 81 from both sides so that the constant's on the left side. and we have our equation written in general form. Given the coordinates of the vertices and the foci, we should be able to write the equation of the ellipse in standard form. So first thing we want to determine is the center. The center is going to have the same, well, if I look at the vertices are on the major axis. So since the y coordinates of the vertices are the same, that tells me that the ellipse is vertically aligned. So the x coordinates, the y coordinate of the center is going to be the same as the y coordinate of the vertices. And then to find the x coordinate of the center, I'm just going to take the, find out what the midpoint is for the x coordinates of the vertices. So I'm going to add 17 over 2 and negative 15 over 2 and then divide by 2. When I do that, I get 1/2. So the coordinate of the center is 1/2 comma 19 over 2. And then I can calculate C. C I will calculate by setting 4 root 7 plus 1 over 2, which is the x coordinate of one of the foci, equal to the center plus C. So whenever you add C to the x coordinate of the center, you get the x coordinate of the x coordinate of the center plus C equals the x coordinate of the foci. So when we subtract 1/2 from 4 root 7 plus 1 over 2, we have a common denominator. We get 4 root 7 over 2. So that tells us that A is equal to 17 over 2 minus 1/2, which is 8. C squared equals A squared minus B squared. So if we plug in 4 root 7 over 2 for C, plug in 8 for A, we can calculate B, which is going to be the square root of 36 or 6. So that means that x minus 1/2 squared over 64 plus y minus 19 over 2 squared over 36 equals 1. That will be our equation of the ellipse in standard form. And the last example, we're given the eccentricity. Eccentricity is C over A, so we know C is the square root of 21, A is 11, and the covertices give us the endpoints of the minor axis. So to find out what the x coordinate of the center is, we're going to take the average of the x coordinates of the covertice. So 13 plus negative 7 divided by 2, which is 3. So the x coordinate of the center is 3. The y coordinate of the center is going to be the same as the covertices, which is 10. Again, C is the square root of 21, A is 11. And so now we can calculate B, since C squared equals A squared minus B squared. So B is going to equal the square root of 100, or 10. So x minus the x coordinate of the center, 3 squared, all that over A squared, which is, over B squared, which is 100, plus y minus the y coordinate of the center, which is 10, all that over A squared. A is 11, 11 squared is 121, equals 1.